Hello folks, now I'm going to go ahead and finish up the crater analysis for the South China Sea Impactor. Unfortunately, because of the turbulence and all that material getting kind of melted down on our planet, it pretty much wiped out just about any effect I might have gotten to where I could possibly determine a trajectory of that particular impactor. So I'm going to go down here to my PowerPoint, and it's not exactly, I mean, earlier on I said that it had to have been like, a direct hit, but actually if it was a direct hit it would have had like more like a central peak, like the Bermuda Rise, and it doesn't. It has blast ripples, as you see right through here, kind of like going around the little circle, and it has the B2W, of which is indicative of it being a high angle but not a direct hit. So the B2W, what I'm looking for was basically some sort of indication where I could measure the high angle blast from the pop to the actual B2W edge, and then from the B2W edge to the from the B2W edge to the first blast ring. But the first blast ring here is really not helpful because it's right on the B2W, and I know that doesn't, I mean, I'm calling it a blast ring, but basically it's the outer limits of the circle encompassing the blast ripples. And because of how violent this material moved in and around here, it's just crazy to imagine that there would be any evidence left to suggest what it is we're looking for. This is Google Earth active right now, and basically we're kind of looking at the Earth as it flies through space, and the red line here represents the solar ecliptic in relation to the Earth. And of course, here's the yellow line for the equator, the Tropic of Cancer toward the north, the Tropic of Capricorn toward the south. This is the top of the planet, bottom of the planet over here by Antarctica. And as you can see, the POO, point of origin, if you take the azimuth from the pop, which is where my cursor is now, and follow it out in this direction, center of the two left and right limits of the B2W, that gives you the direction of the POO. You pull that back azimuth back out here, and that's kind of where your round your impactor came from. But now from this particular viewpoint, because it's like 3D-ish, but you can't get a trajectory on it, so you can't really draw like three-dimensional lines on Google Earth. So it's kind of hard to say where it came in at, but basically this isn't exactly how the planet was set in relation to the galaxy, and that's the one that we get when we look at this slide right here. So here's Google Earth when you take the planet and you orient it with the galactic plane, which is between this yellow line and this yellow line. The tropics of Capricorn and Cancer are in different locations, and and so even though I had to look at this, I'm like, what's going on here? Okay, so the cursor is over here by Tropic of Capricorn. Tropic of Capricorn is not parallel to this line to suggest this yellow line is the Tropic of Capricorn. This is my galactic line. Tropic of Capricorn title is associated with this line going up this way. And then of course this line here is our ecliptic. And when we orient the Earth in this manner, you can see how the North Pole is just slightly above the galactic plane, because it's kind of like the bow of a boat in a sense. Actually, that is exactly what it's doing. you have waves, you have these supermassive electromagnetic gravity waves running around the galaxy, and the Earth is like, and the whole solar system, as a matter of fact, is like an albatross. Maybe swimming a little bit, but in terms of rise and fall, it rises, the solar system rises when the crest of the Smeagol approaches, and then falls as the crest, or as the Smeagol passes at its lowest point, before the next Smeagol comes 11 years later. Yeah, 11 years. Imagine that. So basically our solar maximum occurs when the Smeagols reach their highest elevation of the crest, when the solar system is at its greatest crest point, where it's just a little more turbulent up there, and then when it falls back down, it's in peace. And when it hits the lowest point of the galactic waves, then it's docile. It's at its solar minimum. Okay, so basically what that means is the Smeagols agitate the sun. They piss it off. The sun has an attitude. All right, so anyhow, the Earth is kind of, the sun, the Earth, all the planets are kind of like boats floating, going down the waves like this, like a surfboard. All that stuff. Same physics. All right. Now that seems to make it all make sense now, doesn't it? Pretty much. Okay, so we see that you can barely view the impact site from this particular perspective of the Earth. And it's pretty much obvious right there at that point that we got clobbered on top of the planet. Well, which the top of the planet is the North Pole, but in the sense of our orientation in terms of the top of the sheet, it's up here at the top. But if you notice, because of the ecliptic, the solar system is running around our planet on this sort of plane, and that puts this particular impactor right about in that zone for, like, if I had the Tropic of Cancer and Tropic of Capricorn drawn out to illustrate the width, if you call it that, or the depth of our solar system, then you would most definitely see this particular impactor fall right pretty close right inside of that belt. And that tells us that it was within the solar system. The impactor could have been within the solar system. Now the thing is, it depends on where the Earth was. If this impactor struck the Earth during the month of December, right, then that means that the Earth was at the lower level of our solar system. When our solar system is like this, it's down here. And if it impacted from the top during December down here at the bottom of this solar system spin, the orbit, right? Then, that finger's supposed to stay still. Then it's going like this. Then that means that the impactor struck from inside our solar system. However, if the Earth was up here at the top of the solar system when the impactor struck, then that could possibly mean that it impacted the Earth. Now, you know what? Now I think I have a better idea. You're going like this, and you got Earth down here in December. That means that the impactor came from the inner solar system. It's still in a solar system, so it either came from inside, it came and hit the Earth from between the sun and the Earth, or it struck in the month of June-ish, when the Earth was up here, and then that means that the impactor would have very possibly come from either the asteroid belt or that other one floating around out there, asteroid belt and the Kuiper belt. So there you go. that's the kind of impact. So that was a massive impactor that struck us. I mean, well, if you think about it, you go out there, I think at the Kuiper Belt is the farthest one away, right? And that's where Pluto hangs out. Well, what if you had a Pluto-sized rock come flying into our planet suddenly? Just something bumped it just right, and the next thing you know, that thing just goes, bam, right into our planet. And so now what I can say is the minimum, the least, or the smallest that this particular impactor could have possibly been was 8.4 kilometers in diameter. It may have been larger than that, depending on the blast string size, distance, ratio from the pop. And because I don't really have, I just can't, I'm just not willing to put my name on this estimation to be any greater than 8.4, because 8.4 takes me to the first BR, blast string, and I'm sticking with that because, that's at least the minimum. It could be larger. It might not be larger. I don't know. So anyhow, it hit the planet up there. Now if we get ourselves on a different viewpoint where we can actually see where it's coming down on the top of the planet, we have the solar system ecliptic right here around the Earth. And, there it is. It's right there. So you get kind of an idea just about where it would have been. So you can imagine the distance of this, the actual Tropic of Cancer and the actual Tropic of Capricorn, and you take that width, that band width, and you put it oriented in relation to the ecliptic, and you can see that the impact site, it would be right around, very close to, but within the Tropic of Cancer to the ecliptic. So, or in this case, the ecliptic Tropic of Cancer. I'm using the same names because either way you look at it, it's still kind of like, it just helps me. I don't know if it helps anyone else. It helps me visualize what's going on out there. Now, the next one I'm going to talk to everyone about is, after this one, is the Little Tully Woolly impactor, which was not a high-angle impactor. This is a high-angle impactor. Little Tully Woolly, on the other hand, is one, a low-angle impactor, and two, it also it didn't just create a low-angle impact crater. It also ended up following up after that with a ricochet furrow. Now, we'll talk about that later because they're going into other things, but there's a lot of evidence to that one that I can expound on and tell you more details about it, and I do give you the trajectory on that one. I also provided the trajectory estimation for a particular impactor that struck the Earth and was recently researched by scientists, and that one came in at about 41 degrees from the Earth, from zero. So you go from here, 41 degrees to you is going this direction, so you're that's about 30, 41, oh, so it came in like this, bam! How do you like that? You like that? Well, those are my sound effects. That's what it sounded like too. It was a bam! Alright, so that pretty much wraps this up, ladies and gentlemen, for the North Banda Basin, the South China Sea Impactor, which is the most devastating impactor that I can describe to anybody, that really knocked our planet off its rock. So, yeah, it was a toughie right there. Okay. Yeah, that ends this one here. Please remember to like and please excuse me, I can't remember these things. It's like, okay, cheers and sneers. No, yes, cheers and jeers are always welcome. And make sure you like it and subscribe. I'm going to go ahead and close this out then, if I can get this to go away. Go away. Dadgummit, Microsoft, make that thing go away. You don't need my Microsoft crap. it says I need to fix. You know what? I get the crap at work all the time too, and it doesn't. Yeah, whatever. All right, so here we go.